So looking at Punnett squares is going to lead us into understanding allele frequencies and the Hardy-Weinberg Principle. So in 1908, Godfrey Hardy, who was an English mathematician, and Wilhelm Weinberg, a German physician, independently demonstrated a principle to confirm that allele and genotype frequencies change over time only if there are forces acting on the population. Their principle became known as the Hardy-Weinberg Principle, and it's often referred to as Hardy-Weinberg equilibrium. The idea behind the Hardy-Weinberg Principle is that in an idealized population, if there are no outside forces acting, then allele and genotype frequencies will not change over time in the population. And this is an important concept because we can use this principle as the null hypothesis for evolutionary change. In other words, we use it to say there's no difference in allele or genotype frequencies over time. If evolutionary forces are acting on a population, by calculating if the allele and genotype frequencies are consistent with what we expect, and assuming that the population meets all the assumptions of Hardy-Weinberg, we know that if it deviates from what we expect, then we can infer that some external force is actually acting on the population. So under Hardy-Weinberg equilibrium, we can predict genotype frequencies from allele frequencies and vice versa, because of the relationship they have under the assumptions of the Hardy-Weinberg Principle. If the Hardy-Weinberg Principle is the null hypothesis, that just means that we're using this idea that there's no change in allele or genotype frequencies. But there are several conditions that need to be met for this principle to hold, by which I mean there are several assumptions that are important to remember. The first is that there can be no difference in survival or reproductive success of individuals. There's also no immigration or emigration, meaning there's no individuals coming into or leaving the population. There's no mutation at the genetic level. The population has to be really large, so there's no random genetic drift happening. And there has to be random mating among all individuals within the population. When these conditions are met, and the Hardy-Weinberg equilibrium holds, we can conclude that evolutionary forces are not acting on the genes in the population we are studying. But if allele or genotype frequencies depart from expectations, then we can infer that evolutionary forces are at work.